The surface lifted index is a useful measure of instability used in thunderstorm forecasting. The SLI to 500 hectopascals is the temperature of the environment at that level minus the temperature of the parcel. And so if a parcel of air lifted to 500 hectopascals is warmer than its environment, then the SLI will be negative, and that will indicate instability. The SLI is calculated by lifting a surface parcel dry adiabatically to saturation and then lifting it along a saturated adiabat to 500 hectopascals. This is done for summer, and in winter, in a cooler environment, we use the SLI to 700 hectopascals. Because you can get thunderstorm convection happening in the winter with negative SLIs at 700 but not necessarily at 500. There are two plots of SLI shown here. The top right is observations, and so you can see very stable air over Alice Springs with a value of 20.5 and some unstable air along the east coast of Australia, particularly in Queensland. Below it is model output, and it's showing the SLIs at 500 hectopascals for the territory, and so there's some regions where the SLIs are quite negative. SLI is quite useful because it can be calculated from soundings, hourly metadata if the 500 hectopascal temperature is known, and from prog soundings, so soundings out of models. Use the following surface conditions for a surface pressure of 1000 hectopascals to calculate the SLI in degrees Celsius given an environmental temperature at 500 hectopascals of minus 10 degrees Celsius. Stop the video and calculate these values. So how did you go? For A, the SLI is minus 3.5, and for B, where the surface temperature is 5 degrees Celsius warmer than A, the SLI is minus 6.5. So varying temperature can have a profound impact upon the buoyancy at 500 hectopascals. For C, with cooler temperatures and lower dew points, the SLIs are positive, so this is the only case that's stable, measured by the SLI. So not only does the temperature play a role in the value of the SLI, but so does the dew point. Can you think of any limitations that SLI has? What does the SLI represent? It represents the buoyancy at 500 hectopascals or at 700 hectopascals for the cold season. But it tells you nothing about the vertical distribution of buoyancy, for example, whether or not there's a strong inversion lower down. So on its own, SLI is insufficient, but nonetheless, as a broad brushstroke, it's a really useful diagnostic for thunderstorm forecasting.